In this session, we are going to study the basic electrical terminologies. Now, these are the basic electrical terminologies that we are going to study. The first terminology is electricity. Now, this is not a new term. We are every time or every day we're using the electricity. It says that it is the physical phenomenon associated with the presence and motion of the electric charge. Now, to define the electricity, we are also using the term electric charge. We are going to see what's meant by charge in the later slides. It says that there's a presence and motion of the electric charge. Now, this presence and motion of the electric charge gives you the electricity. It was discovered by the Benjamin Franklin, and this image, the lightning, is also an example of the electricity. So if you want to see more, I think you can visit this link. Now we have again the types of electricity. We have static and dynamic, which means something is not moving here, and in case of dynamic, it's moving. Something is moving in this. So let's see one by one. Static electricity is discovered by Graves. That means it's before the Benjamin Franklin. Now looking at this statement, we can say that Benjamin Franklin has discovered the dynamic electricity. It says that electricity produced by rubbing two non-metallic objects. This is called the static electricity. The electricity produced by rubbing two non-metallic objects. Example, the pieces of paper sticking on the scale when scale is rubbed for few seconds. Now this practical we have done in the lower school, right? By taking scale, rubbing on the here for few seconds, and then when you bring the scale to the pieces of paper, your paper get attracted to the scale. Now this is called the static electricity. And the working is the electrons jump from one object to the other, causing a positive charge in one and a negative charge in the other. Now this is the working, how the paper is being attracted to the rubbing scale. And then the second types of electricity is the dynamic electricity. Is the flow of electric charge through a conductor, or in other words, we can also say that it's flow of the electric current. Now this is called the dynamic electricity. Here there's a movement of the charge. The second terminology is charge. Now charge is represented by the symbol Q. SI unit of the charge is coulomb. The charge is an electrical property of the atomic particles of which matter consists. Now charge is also one of the electrical property in the atom. Charge, you can either have positive charge or the negative charge. The positive charge, we call it as a proton, and the negative charge, we call it as an electron. In 1 coulomb of charge, there are this many number of electrons. So remember this number of, this statement, how it is being related. 1 coulomb of charge, there are 1 by 1.602 times 10 raised to minus 19 electrons, or in other words, it's like 6.24 times 10 raised to 18 electrons. Now from the law of conservation of the charge, it says that charge can neither be created nor be destroyed, but it can only be transferred from one point to another. Now how this charge is being transferred, this thing we are going to discuss in the next slides when we talk about the potential difference. Now here's a homework. It's for 0.5 marks. It's properties of charge. You can write the properties of the charge. And this third terminology is current. Now this image I've retrieved from this link, so you can also have a look for the more image for the better understanding. Now looking at this image, there's a flow of the electrons from the negative to plus, and then direction of the electric current is from plus to minus. Okay, remember that the flow of the electron and the current are in opposite direction. Now current, it describes the charge in motion, or it's a flow of charge, or in other words, this phenomenon, the current, can be result from moving electrons in the conductive material or moving ions in a charged solution. So it's a phenomenon which result from moving electrons in the conductive material or moving ions in a charged solution. Or in other words, you can also define the electric current as the time rate of change of charge, which is measured in the ampere. When you say about the ampere, it's simply the charge by the charge divided by the time. So from this definition, your I is equal to dq by dt. A small change in the charge with respect to time t. Now this is how charge and then the current are being related. So this here's also an example of the flow of electrons and the flow of current. Now from the definition, it says that I is equal to charge over time, and then the unit of the charge is coulomb and the unit of the time is second. So this coulomb by second is called the ampere, or an ampere is the number of electrons having a total charge of 1 coulomb moving through a given cross section in 1 second. So this is, if you know the definition of the current, then it's very easy to define the ampere. As defined, current flows in direction of positive charge flow. So I've also shown you the two image, how the charge from where to where the charge is being flowing, or how the current is being flowing. It says that the current flows from positive charge to the negative charge, whereas the electrons flow from negative to positive. They are in opposite. The flow of charge and flow of current are in opposite. And then 1 ampere is equal to 1 coulomb by 1 second. And then if the charge transfer from time t naught to t, then we can also determine the magnitude of the number of charge. So Q is integral from t naught to t. We are integrating the current with respect to time t. So with this, so we can compare the relationship between current and the charge. If you know the magnitude of the charge, magnitude of the current, then you can determine the charge. If you know the charge, you can determine the magnitude of the current. Electric current is defined as the electrons flowing between 2 points having a potential difference, which means if there's no potential difference, then there will be no flow of the charge, which means there's no flow of the current. So here in this line, it says that how we get the electric shock. Man gets electric shock only when there is difference in the voltage level. For example, when the birds are resting on the live conductor,